Let's work through this geometry problem carefully, because the final answer is surprisingly simple, but the reason behind it is a really beautiful piece of geometry. We have a trapezoid called PQRS, with the top base PQ parallel to the bottom base SR. On the right leg, QR, we have a point O. And the important condition is that O is exactly the midpoint of QR. So we know that QO equals OR. Now we connect O to the two opposite vertices on the left, P and S. That divides the trapezoid into three triangles. We are told that the upper triangle PQO has an area of 4 square units, and the lower triangle SRO has an area of 7 square units. The question is, what is the area of the middle triangle PSO? Before we jump into the construction, pause for a moment and see if you can find a pattern. If you enjoy these geometry challenges, this is a good one to think about before continuing, and you can always leave your answer in the comments before seeing the solution. Now, at first, you might think we need the lengths of the sides, the height of the trapezoid, or perhaps some angle measurements. But we actually don't need any of those. The key information is that O is the midpoint of QR. So let's use that midpoint to create an auxiliary figure that will reveal the hidden relationship between the three triangles. We are going to extend the top and bottom bases and construct a parallelogram on the right side of the trapezoid. Through O, draw a line parallel to the left side PS. Let this new line meet the extended top base at a point T and the extended bottom base at a point U. Because the top and bottom bases are parallel, and because TO is parallel to U, R, the new shape formed on the right is a parallelogram. Now, pay close attention, because this construction gives us two small triangles that are extremely useful. We have the triangle involving the upper point T, the midpoint O, and the top right vertex Q, and we have the corresponding triangle involving the bottom right vertex R, the midpoint O, and the lower point U. The reason these triangles are important is that we can prove that they are congruent. Let's look at the first pair of angles. The lines QOR and TOU intersect at O. Whenever two straight lines intersect, the opposite angles are equal. These are called vertical angles. Therefore, the angle TOQ equals the angle UOR. So we already have one pair of equal angles. Now, let's find another pair. Remember that the top and bottom bases of the trapezoid are parallel. Since the line QR is a transversal crossing those parallel lines, the alternate interior angles are equal. Therefore, the angle at Q in the upper triangle is equal to the corresponding angle at R in the lower triangle. So now we have two pairs of equal angles. But we also have one more important piece of information. O is the midpoint of QR. By definition, a midpoint divides a segment into two equal parts. Therefore, QO equals OR. So the two triangles have two equal angles, and the side between those angles is also equal. By the angle-side-angle congruence theorem, the two triangles are congruent. And if two triangles are congruent, their areas are equal as well. This is the hidden mechanism that makes the entire problem work. Now, let's introduce a little algebra so that we can track the areas without needing any actual side lengths. Consider the small triangle formed between the lower left vertex S, the lower point U, and O. Instead of trying to determine its area directly, let's call its area X. So the area of triangle SRO is given as 7 square units. That entire triangle can be thought of as two smaller pieces. the triangle SUO, whose area is X, and the remaining triangle URO. Therefore, because the total area is 7, the remaining piece must have an area of 7 minus X. This is simply subtraction of areas. Now let's move to the upper part. We are told that triangle PQO has an area of 4 square units. From the congruent triangles we established earlier, the corresponding auxiliary triangle has the same area as the piece with area X. So when those two pieces are combined, the larger upper triangle has area 4 plus X. Notice what is happening here. We don't actually know what X is, and that's completely fine. We're deliberately leaving it unknown because we expect it to cancel later. Now, we need one more useful construction. Draw a line through O parallel to the bases of the trapezoid. Let this line intersect the diagonal structure of our parallelogram at a point. This divides our construction into 2 smaller parallelograms, one above O and one below O. Now we use a fundamental property of parallelograms. If you draw a diagonal inside a parallelogram, that diagonal divides the parallelogram into 2 triangles with equal areas. The reason is that the 2 triangles have equal bases and the same perpendicular height, so their areas must be equal. Look first at the upper parallelogram. The relevant diagonal divides it into 2 equal area triangles. One of those triangles corresponds to the upper portion, whose area we already determined to be 4 plus X. Therefore, the part belonging to the middle triangle also has area 4 plus X. Now apply exactly the same idea to the lower parallelogram. Its diagonal divides it into 2 equal area triangles. We already determined that the corresponding lower piece has area 7 minus X. Therefore, the other half also has area 7 minus X. And now we have everything we need. The middle triangle PSO is made from those 2 pieces, so its area is the sum of the upper contribution and the lower contribution. Therefore, the area of triangle PSO equals 4 plus X plus 7 minus X. Let's simplify this carefully. We have 4 plus X plus 7 minus X. First combine the constant numbers. 4 plus 7 equals 11. Then look at the variable terms. Plus X minus X equals 0. They cancel completely. So, we are left with 11. Therefore, the area of the middle triangle PSO is 11 square units. And notice how clever this is. We never had to find X. We introduced X only to keep track of the 2 unknown pieces, and because one appears as plus X, while the other appears as minus X, the unknown disappears automatically. This is a very common and powerful idea in geometry. Sometimes you don't need to calculate an unknown quantity if you can arrange the problem so that the unknown cancels. So our final result is very clean. The upper triangle has area 4, the lower triangle has area 7. And because O is the midpoint of the trapezoid's leg, the middle triangle has an area equal to their sum. In other words, 4 plus 7 equals 11. So the middle area is 11 square units. The important lesson is not just the number 11. The real lesson is the geometric relationship behind it. Whenever a point lies exactly at the midpoint of one leg of a trapezoid, and you connect that point to the 2 opposite vertices, the area of the middle triangle equals the sum of the areas of the 2 outer triangles. The parallelogram construction is what exposes that relationship. If this trick was new to you, definitely remember the midpoint condition, because that is the clue you should look for in similar problems. And if you recognize the shortcut before we finish the construction, let me know in the comments. Also, if you found this explanation useful, you can like the video and subscribe for more geometry problems like this.